In this video, I'm going to solve a few questions on the hypothesis testing for the one sample proportion and the mean. The first problem here is about this one sample proportion. From previous studies, it is concluded that 77% of workers indicate that they are mildly dissatisfied with their job. A researcher claims it has decreased and decides to survey 100 adults. Now, that's the researcher claim at the level of significant alpha equals 0.01. So the first question is, it is safe to assume that n, the sample, is less than or equal to 5% of all the subjects in the population, and we only have 100 adults, so the answer should be yes, right? This is much smaller than all the subjects in the entire population. And then next thing is we need to verify n p hat 1 minus p hat is bigger than or equal to 10. And why do we need to check for these conditions? Well, the population must be much larger than the sample, at least 20 times as large, so that the sample items are independent. And the assumption that both the n p hat 1 minus p hat is bigger than 10 to ensure that the sampling distribution of the p hat is approximately normal when we assume that the null hypothesis is true. And the next we verify that n p hat 1 minus p hat is bigger than or equal to 10. So you take 100 multiplied by the original assumptions, 0.77. Make sure you convert this to decimal value. And then 1 minus 0.77. And that will give me 17.7. This is bigger than 10. And then now let's test the claim. Express the null and the alternative hypothesis in symbolic form for this claim. So originally, we assumed that the null hypothesis is when the proportion is equal to 0.77, and then the researchers claim that it has decreased. So the proportion now should be less than this amount. Decrease means less than. So for that is the alternative hypothesis, the H1, or sometimes we use the HA, doesn't matter which one we are using. That's just a notation from different textbook. And P should be less than. Decrease, that means it's less than the original assumption. So this is the claim from the researcher. And then the next questions. After surveying 100 adult Americans, okay, that is the sample size 100, the researchers find that 64, that is the number of the subjects that indicates that they are mildly dissatisfied with their job. So X is 64. Now compute the test statistics, which is Z, the Z statistics in this case. This is the proportion. So go back to the parameter we are looking here is the proportion P. And the sampling distribution that we are using is the normal Z, and we have the requirements checked, which is okay to use the normal Z distributions. And then now the test statistics is followed by this formula. So the test statistic we are looking for is Z naught is going to be equal to P hat minus P naught, and then the square root of P naught and then Q naught over N. So now let's go back to the questions. I know that I can find P hat, which is the point estimate in this case, which is X over N, after the researchers did the survey, and then they found that 64 for X, the worker, says that they mildly dissatisfied with their job, so that's over 100, or 0.64. And then P naught is the original proportion, which is this value right here, P naught. So I can plug in the number 0.64 minus P naught, which is 0.77, and then divide by P naught is 0.77, and then Q naught, this is the complement of P naught, or 1 minus P naught, or 1 minus 0.77, and then all over divide by n, which is the sample size. And now let's do the calculation right here. So I take the square root of 0.77 and then multiply 1 minus 0.77 and then all over divide by 100, and then I take the top value 0.64 minus 0.77 and then divide the answer I just got earlier, and the value is negative 3.089 is the test statistic. This is the correct answer right here. Okay, and then after you got the test statistic, you can find the p-value. So we know that we follow the normal distribution for the sampling distribution, and then this is the left tail, right? Because less than is pointing to the left, so this is the left tail, and then I know that for the left tail, this is negative z naught, and then this is z naught. So this is negative value, so that is right here, negative 3.089, and I know that this is the left tail, so I need to find the area of the left tail. That will give me the p-value. And I know that this is the normal distribution. To find the area of that, I would use my TI-84 to help me for that. So I go to second var to get me to distribution, and then this is the normal distributions, so I am going to use normal CDF. Okay, so the lower bound we want all the way to the left, so I put a very negative number, and then the upper bound I want to go up to negative 3.089, negative 3.089, and then the mean is 0, the standard deviation is 1. This is a standard normal curve, and that will give me 0.0001. 0.001 is the p-value. So right here, 0.0001 is the p-value. This is the correct answer right here. Okay, and because the p-value, let's compare that to the significant level, which is 0.05. So it's less than 0.05, which is alpha. So the p-value is less than alpha. Therefore, we are going to reject the null hypothesis. If the p-value is less than the level of significant level 0.05, we reject the null hypothesis. If we reject the null hypothesis, if we reject this one, that means we have enough or sufficient evidence to support the alternative hypothesis, or there is sufficient evidence to support the researchers' claim that 77% of workers indicate that they are mildly dissatisfied with their jobs has decreased. So that's how we form the conclusion after we make the decision based on the level of significance. The second question that I'm going to solve in this video is about the hypothesis testing for the one sample mean. A hospital recruiting company for doctors is conducting a study to determine whether the average doctor's salary in thousands of dollars is significantly more than $86,000. A random sample of 28 doctors' salaries in thousands of dollars is given in this table below here. Now test the hospital recruiting company's claim using the one level of significance. So we are looking at the average amount, so that is the mean. So we know that we are looking at the mean of the sample. and then we are given the level of significance alpha is 0.01 because that is 1%. So in this case, the hospital recruiting company claimed that whether it's conducting a study to determine whether the average doctor salary is significantly more than mean bigger than, right? So the original assumption is that H1, H0, the null hypothesis is when the mean, because we are talking about the average. So the original assumption is that we are only having the mean of like 86,000 for salary, and then the researcher, the study, they want to see if that is significantly more than, which is bigger than 86,000. So this is the claim that we are testing right here. We are testing right here for the doctor salary. So the null hypothesis is when the mean equal 86, and then the alternative hypothesis is when it is bigger than 86, which is the claim. Now, before we do the claim, make sure that we also need to check it is safe to assume that the sample size is less than or equal to 5% of all the doctor earning salary. And we are looking at 1, 2, 3, 4, 5, and then we have 25, 26, 27. We have only 28. So the table here displays only 28 the values of the doctor's salary, and we have a lot of doctors in the US. So 28 is surely less than 5% of all the doctors earning salary. So yes, the answer is yes. It is safe to say that it is less than 5%. In this case, the mean is not bigger than or equal to 30. So, sorry, the sample size is not bigger than or equal to 30. So we consider this sample size is small. It's small. So now the mean, if the sample size is not bigger than 30, then there may be a problem of using the distribution right here, the formula. So we have to check to make sure that the sample does come from a normally distributed population. So how do we check that? We can use a normal probability plot to check for that, or we can use a box plot of the salaries containing to see if it contains any outliers. So this is the given box plot, and then you see that it looks like that it is a good box plot, and there are not any outliers from the box plot, which is okay, right? Because the sample size is less than 30. So after we check everything, then now we are ready to find a test statistic. Follows the hypothesis setup right here. So how do I find a test statistic? So let's go back to our formula. We are talking about the mean. So these two cases. And then there are two cases. If we do know the population standard deviations, then we can apply the normal Z for the sampling distribution. If we don't know anything about sigma or the population standard deviation, then we must use the student T sampling distribution. According to this problem, we are not given anything about the population standard deviation, and therefore we must find the test statistic using the student's T, this formula right here. So I'm using this formula T naught equal x bar minus mu naught S over square root of n. And then go back to our problems. Go back to our data. The x bar is the sample mean of all the doctor's salary. So we can find the sample mean, and we can also find the sample standard deviation small s of the data. by using the graphing TI-84 calculator. So first thing is I go to Start, I go to Edit, and I want to enter all the number of the table into the list of L1. So after you enter all the value into the list L1, we are going to use the function on the Start. Go to Calculation, click on one variable statistic, the list L1, and then you got everything here. Okay, the X bar, the sample mean, is given right here, 93.047, and then the S sample standard deviation, 4.87 right here. Alright, so we have everything, and then the original assumption of the mean value, mu naught. So I have 93.047 minus 86 divided by S, 4.872, and then 0.28. So let me do this calculation quickly here. So take that, divide by square root of 28, and I take the numerator, subtract 86, and then I divide this number 7.047 divided by the number we got earlier, and that should give me the test statistic of 7.6537, around that. And let's check the answer. The answer is right here, so that is correct. Okay, right here. And then we can find the p-value. Again, this is pointing to the right, so this is the right tail. So I know that I can draw the normal curve, and then T naught is right here. The right tail pointing to the right. So we are looking for this area, which is a p-value. So this is the student T. So I must use second distribution, the TCDF. So the lower bound is this number, and then you want the right tail, you want all the way to the right, the upper. So I want all the way to the right, a huge positive number. The degree of freedom is n minus 1. We have 28 sample size minus 1, so 28 minus 1 or 27, and then you are going to get the p-value is 1. It's very small, extremely small in this case, 1.56 times 10 to the negative 8. It's very small. So that you see that if you rewrite it as a decimal value, so 0.00000019, it's very small. It's very small to the negative 8, and they are using some type of rounding here, so you may not get exactly the decimal places, but you should get like 10 to the negative 8. So this is very small, and you can consider this one to be like almost 0 because it's very extremely small. So think about the p-values like approximately like 0, because this is very small, and 0 is, of course, it's less than the level of significant alpha, which is 0.01. If it's less than alpha, we reject the null hypothesis. And if we reject the null hypothesis, then we have enough evidence to support the claim. So there's enough evidence to support the claim that the population's mean doctor's salary is significantly more than $86,000.